Cool. All right.
So go ahead. Good luck.
Thank you. If there's any questions along the way, don't have any technical demos. I'm not going to have any virtual machines that are going to shut down on me, luckily. But a really good tip by Barbara: shut your stuff down if you don't need it. And it's better to shut it down sometimes when you need it than have it running all the time when you don't need it. So if there's any questions along the way when I talk, I'm gonna have an eye on the chat window. So just interrupt me and ask. Happy to answer any questions. All right. Well, thanks for having me at this late hour for all the Belgian people here on the call, which is probably everybody. I think there's a few Dutch people, but yeah, it's 10 p.m. No, it's 9:15 for you, so it's not that late. To hear about how we build a cloud security product on Azure, specifically a cloud security posture management product, a SaaS application, a software as a service. Gonna go quite technical today, like quite deep into how we build things and what technologies we've used, and but I'm going to start where probably everybody starts. Who's this person here? David O'Brien. Some of you have maybe heard of me before. I'm a Microsoft Azure MVP. I'm also the founder of ARGOS Cloud Security. And if you want to get in touch with me, here's my contact details, Twitter, the company's Twitter account, my blog, and the company's URL website address. On the right, family and beautiful Melbourne, where I actually don't live anymore. We've moved further south to Geelong, a very, very nice city down by the coast. But just to put that out of the way, I am German, so I'm actually not from too far away from where you are. Well, German Scottish, so that's why this is not how Australians sound. It's not an Aussie accent here, and I can't fake one, so I'm not going to pretend. All right, what is cloud security posture management? If you've not really done much of cloud security before, and I argue if you're doing anything around networking, anything about patching, anything about identity, then you have done security, then you work in InfoSec. But this particular category of product, CSPM, is a Gartner category. So Gartner came up with that, as they usually do. And products like ARGOS, ours, or Security Center has a CSPM, Azure Security Center has a CSPM capability. And what these products usually do is they monitor and scan a cloud environment and tell you what kind of security issues you have. And there's certain aspects to it. Some of them have a very compliance-heavy focus. Ours have a very security-heavy focus. The difference can be very small sometimes, and you can argue that security is a subset of compliance and they go hand in hand, but a cloud security posture management product at a high level would tell you, for example, if you have a port open on a virtual machine that should not be open, for example. In our opinion, what makes a good CSPM, or in my opinion, it's easy to use. Like every product should be frictionless, it should be agentless, you should not be asked to deploy another agent onto stuff. And I believe it should be focused on security, which is funny because it's called Cloud Security Posture Management system or product. Most of those really only focus on compliance. And I believe that our product is, without being salesy or getting salesy here, is very focused on security. And it's important to understand that compliance does not equal security. You can be very, very compliant in your environment and at your organization and still be insecure. You can also be very secure and still incompliant. So there's also that. A CSPM should answer context and give context, answer the so what question, be helpful, should not just go and say, here's a problem, and then have a person go and figure out what the problem actually means. It should detect issues in real time or near real time as soon as possible and not only once a quarter. That's a compliance check, that's not a security check. And also create minimal noise. There's then always the how many false positives should we have compared to false negatives? Should we have lean more towards false positives and alert in areas where we shouldn't have alerted or in things we shouldn't have alerted on? Or should we have maybe rather have fewer alerts and maybe miss something? We lean more towards have an alert for something that maybe shouldn't have been alerted on, so that we don't miss anything. That's what the industry usually does. And some products then just go and create way too much noise and people just stop looking at them. And the whole premise of why I started this company is because, and this is a very big claim, is that I believe that as an industry, we all still get cloud security basics wrong. Not a day goes by that we not read about another database. I think just the other day there was one of those smart watches, those fitness watches vendors. They had a database on the internet and leaked millions of customer data entries. Why does this still happen? How can that still happen in 2021 when these things have always been areas of concern for 10, 15, 20 years in IT? Never should you have put a database right on the internet, and yet still we're doing it. So who needs a CSPM? I believe everybody with a cloud footprint should have some sort of CSPM capability. So that's why Microsoft, for example, has Security Center. But you should really get the one that you need. And that is dependent on, do you want to just monitor for compliance? Do you want to monitor for security? Do you want to maybe do both? And at the same time, understand, though, there's no silver bullet. There's plenty of vendors that go, just buy this one thing and we do everything for you. And I always go with, maybe there's some car nerds here. It's very difficult to buy a car that is super, super comfortable and goes really, really fast and goes really, really fast around the corners, but also doesn't consume that much petrol at the same time. So you really have to decide sometimes. This all-in-one solution is most likely a myth. Just because this is a very Azure-focused user group, how is this different? How is our product different to Security Center? And that's just at a very high level. Security Center is amazing at mapping things to regulatory compliance. It can easily tell you you're this much percent compliant to PCI or CIS or ISO 27001. I believe it's not great at actually showing you context. It's not great at showing you this misconfiguration relates in your environment in such a way to other things, and because of that, it's a security issue. Yeah, often it will tell you, for example, this storage account is said to be public. But then you go and investigate that storage account and you see actually there's a firewall on it. So it doesn't really matter what the container thinks it's supposed to do. There's a firewall on that storage account, and it's got a VNet service endpoint, and it's got a private link. So yes, it's misconfigured, it's not compliant, but it's actually secured with other things. And that's where I believe the difference between compliance monitoring and security monitoring comes in. All right, enough high level. And what's a CSPM? How did we build it? And at some point, I had a trigger moment with a customer that got hacked. And it was really because they had a misconfiguration and a product didn't catch it. And I believe we can build something better. And we did. Spoiler alert. But how did we do it? We sat down and I sat down and wrote down these golden rules for our product. And it had to be all in on Azure. I don't believe in multi-cloud for a single application. Rubbish, in my opinion. So all in on one Azure. Vendor lock-in is a good thing because then you can actually go and leverage. Then you can actually go and leverage the. Sorry, everything just stopped here for a second. Okay, I think I'm back. Am I still on?
Yeah, your sound is on, but your video is gone, David.
Yeah, okay, interesting.
But yeah, just go ahead.
The slides are still there.
Okay, yeah, slides are there, your sound is there, so no worries.
I just got a lot of ding dongs here. All right. So all in on Azure so that we can actually leverage the platform as much as possible and get the most cost savings and, as you see on the next slides, actually build a proper integrated product. And we wanted to use PaaS as much as possible. No virtual machines, no wondering how we're going to patch this thing. No Microsoft, unfortunately, deploying agents onto our virtual machines that drop authentication headers if we're not sending them. None of that was an issue for us, or what we wanted to be an issue for us. So we said PaaS if possible. We're a security product, so we obviously needed a very strict focus on security. Also a startup, and if there's any business owners here, ARGOS is fully bootstrapped, which means it's all my personal money, how I started the company. So I needed to make sure that we don't spend too much money. So one of the rules was, for as long as we can, free tier as much as possible. And in that same thought, use third-party solutions with startup tiers. If we had to integrate with a third party, then a lot of products nowadays have startup tiers where they give you 12 months for free, for example, or for a very low fee. That goes hand in hand with buy over build. I'm a very big believer in buy over build. If there's somebody who's developed something, a product on the internet that does something that I need, then why do I believe that I can build it better and get distracted from my business objective, my product, because I think I can do email better than a SendGrid, for example. So buy over build. And over the last 12, 13 years in IT, from day one, I had to automate everything, and I still have to automate everything. If it can be automated, and almost everything can, we automated it. So in the end, we came up with this architecture here. So if anybody's seen any of my previous sessions, I used to have our very original drawing, which was really a back of the napkin drawing for an architecture. This is now a bit more evolved. And the core functionality of our application is here in the middle. which is our .NET Core. So ARGOS runs on .NET, and there's no secrets or trade secrets in here. It's all .NET Core running on Linux Azure functions. So our application is written in .NET and C#, but runs on a Linux Azure function worker. We use Cosmos DB as our backend, so NoSQL database. We put all our secrets into a key vault, and that's where they're encrypted and kept as encrypted at rest, and same in our database. Everything we choose to encrypt gets encrypted with key vault encryption keys. We log everything into application insights. Everything has an asterisk nowadays because application insights is not cheap. The Azure functions, as I mentioned, on Linux, it's actually durable functions that we use. So we have a storage account that manages the state for that. And then we get into our third-party integrations. So for payments, we integrate into Stripe because PCI compliance is really, really difficult and a hard headache. So we just offload that again, buy over build. We offload that to Stripe, so we don't have to be PCI compliant. SendGrid, because I don't believe I can do email very well. They can. And Auth0 here in the top right as our identity provider. And we use Auth0 to integrate into Azure Active Directory and G Suite identities. Our front end is just an Angular static web app running on a storage account or behind an Azure CDN. And that's how we then integrate into all three cloud providers to scan them for security issues. So at a high level, that's what ARGOS looks like. So let's go a bit deeper into that. Our front end, as I mentioned, we're running on an Azure storage account as a static website. Why? That's mainly because we can just build the Angular app, copy it to storage account, and that's it. That's all we have to do. It's very well known how Angular works in the industry. It's easy to find people that can write Angular. The Azure CDN is super helpful for our customers here in Australia and in Europe to have very good performance on the front end. And really mostly because we don't have to deploy a virtual machine. There's no IIS or Apache web server that we have to worry about. We don't have to patch anything apart from our code, obviously, but I don't have to patch Linux or Windows. That's all been taken care of through the storage account, the storage service. And I don't have to worry about how to deploy a highly available web server. It's all baked into the service for $24 a month. If Barbara was still around, we could ask her how much she pays for her virtual machine every month for a demo virtual machine. Our production web front end costs $24 a month. So I believe that's pretty good. And I think a lot of organizations nowadays are still very hung up on how much they pay for the actual service or not pay for the service, but then forget about the cost for patching, cost for figuring out how to run highly available, cost for understanding how to run IIS highly available. It's all cost, and that usually gets added or should be added from an accounting point of view on top of the $24. So if you don't have to worry about any of that and just worry about $24 plus working on your application, then you're actually very cost efficient. Here we see a bit of code, and that's our to our point around everything automated. So that's Pulumi, P-U-L-U-M-I, Pulumi. Our infrastructure as code framework that we use. So we don't use Terraform, we don't use Bicep, we don't use ARM templates, we use Pulumi, because we can write our infrastructure in TypeScript, which is very, very, very close to Angular, which means that everybody who can write our application, everybody who can develop on our front end and even back end, because Pulumi also supports C# deployments, can actually go and deploy our infrastructure as well and write and make changes to our infrastructure. And in order to deploy this application, this front end, or the infrastructure for that front end, this is all we have to do. And you can see we configure things like enable HTTPS traffic only. We have the replication set. So that's all we have to worry about. And I think that's pretty good. That's really all we need to do. No deploy 2, 3 virtual machines and deploy them in multiple regions. Yeah? Again, we have that CDN. We just deploy it into one region, and the CDN takes care of the web traffic itself. Let's go a bit into a bit more interesting, I think, our application infrastructure, the actual app layer, the Azure functions. As I mentioned, we run on Linux, and it used to be on a dynamic consumption plan. Again, because we wanted to be free for on a free tier for very long, if possible, and you get quite nice credits on that consumption plan. And it's nice because it scales in all dimensions. It scales up and down and in and out, however you need it. And you no need to patch anything. Again, just like on the storage account, except for our code. That's all we needed to worry about. To deploy Azure functions, we need the app service plan here, even on the consumption plan. But you just tell it in Pulumi to be a dynamic size Y1, and the actual function app on the right here. Again, you can see HTTPS only. We use the system assigned identities to communicate with other Azure services. This also goes back to the secure by default or focus on security approach that we're taking, where we don't have any credentials hard-coded anywhere. Everything's managed identities or keys that we have in Key Vault. So nothing in our code. On the left here, however, you can already see we had that feeling that we're not going to be able to stick around on the free plan, on the consumption plan for too long. So we already had it commented out if we have to go to the premium plan, that this is what we would have to do. So the OG version of our infrastructure looked a bit like this on the Azure functions. We had a timer triggered function, which was triggered every couple of minutes. That put a lot of messages onto a storage queue, and then because of that, there was one queue triggered function which automatically scaled based on the number of messages in that storage queue. And we quickly realized that this is a nice pattern, but it doesn't actually work too well for us because we do actually execute a lot of asynchronous activities. I'm now going to give it away. Activities that the main function needs to call, but needs to wait on, and then the main function needs to do something else, so that it can go and tell something else what to do. So, or that something happened. And that's really difficult to do here in this construct, because we could have gone and have every one of these put another message onto another queue, and then that queue triggered another function. And then you're suddenly very quickly having this cascade of storage queues around that you all have to manage. And my camera is not happy this morning, so sorry for that. So because of that, we came up with the durable functions. Well, we didn't come up with it, but we thought we were going to use durable functions, and that's what we're now using. So we still have this timer-triggered orchestration that runs whenever it runs, and it goes and calls asynchronously these activities. So it essentially kind of still goes with queues, but it calls these activities, and then it kind of waits for those activities to do its thing. It kind of goes back to sleep, but it doesn't stop until these activities then notify that main orchestration again and say, hey, we're done, we're all done, or because it knows it might have just triggered 1,000 activities here. So it waits until all 1,000 activities tell it to continue. We're all done. We've all done what we had to do. Now it can continue its own thing. And yeah, you could then have it continue, and that's, as a matter of fact, what we do. After it has done its first thing, we might call another set of activities, which the main orchestration then waits for. So you can easily do this workflow almost. And I know we just had a PowerShell demo. This can almost be seen like PowerShell workflows. I sometimes, when I started on durable functions, thought it reminded me a bit of PowerShell workflows, but it's all managed and works very well. So the reason why I went with functions is it really scales very well. It scales automatically. Sometimes you have to do something, but on the free plan, it just scales automatically. And as I said, we were initially on the free plan, but we knew we could easily deploy our infrastructure into that dedicated app service plan. And on the OG version of our application, and still with durable functions, because it heavily uses queues, and queues come with a high durability SLA, or SLO actually, we didn't really have to worry about missing any messages. That means whatever goes into the system, we're very, very confident that it will be picked up by our application and then eventually be worked on. And we didn't have to worry too much about missing any messages from customers. So we had this, and then this happened. Our metrics, and it is a .NET application, so it is a bit more memory heavy, I believe, but we quickly saw, so that red line I put in, which is about 1.5 gigabytes. And we very soon saw that our memory working set steadily climbed above 1.5 gigabytes. And the interesting thing about that is that on the free plan, you only get up to 1.5 gigabytes. And after that, the function workers, if they need more than 1.5 gigabytes, shut down. So it really is a good problem to have in our case. We added new features, the application grew, there was more load on it through daily active users working on the application. It's a good problem to have. It's good to see more load on the application. So it wasn't a memory leak or something. It wasn't bad development on our side. It was really, the application just grew and it got more mature and more things were added. So we realized what we already knew before. We're now at this point where we're now memory constrained. And to give that away, we're still only at 1.7 gigabytes, probably. Well, we were somewhere around 1.5 gigabytes of memory consumption, but we sometimes tip over, and just so we don't have the worker shut down anymore, we decided we were going to go and deploy into the premium plan. And it's not actually that expensive now anymore, anyways. And if you remember back to how we deployed the app service plan initially, we had the the dynamic Y1, and we already had it commented out in the code. All we had to do was change the tier to Elastic Premium and put the EP1 size in here, commit to Git, and have our pipeline deploy the infrastructure. And that's all we had to do. 10 minutes later, we were running on the premium plan. So that was the middle tier. How about our backend? I mentioned Cosmos DB, and really we used Cosmos DB initially because it also had a free tier. And there's a lot of people now that go and on the internet look for jobs using NoSQL technologies. Our data is quite unstructured by nature, and so we decided Cosmos DB plus its very high or low read, very low read times and write times would be a good fit. After free tier, we initially paid around $600 a month. But I'm very, very confident that the database is not actually optimized yet. We're still writing too often to the database, which costs money. We still write too much to the database, which costs money. So we could bring that cost down quite a bit. Another reason for Cosmos DB was that it's really, really easy to use with Azure functions. Remember back when I said all in on Azure? That's one example of that. Writing from an Azure function to a Cosmos DB database, Cosmos DB container, is a one-liner. If that's all you need, if you don't need to do anything else, it's one line. It's return the object, and that's it. Because Azure functions, through their output bindings, can very, very easily just go and write stuff to Cosmos or any other binding integration. So that's an example for if you were thinking about, but what if I wanted to write to a different database on a different cloud or something else, then you'd be writing a lot of code that if you just focused on that one cloud, you didn't have to write. It's also a PaaS service, which fits another one of our golden rules, which means no patching. Cosmos DB has HA for free, basically, out of the box, with 4 data replicas in one region. And if we needed more regions, then you can here on the right see our Pulumi code. Then we just would add another location in here, and our data would be replicated to a different region. Very, very easy, and not too much to worry about. Cosmos DB also can scale on demand. So it has auto-scaling baked into it. If we didn't want to have auto-scaling, then we can also define a fix RU. That's a request unit. That's something you need to get used to with Cosmos DB. That every time you read, every time you write, it actually costs money. So it's good. It makes you think about your application design and when to write, when to read, how to write, how to read. There's a really good tweet just yesterday where someone had a tiny, tiny difference in a query, which made a massive cost difference, even though the output was the same. So the request units is something you need to get used to. But yeah, interestingly, it wasn't really too much of an issue for us at that point initially. However, currently we now have around 44 million requests every month to our database, 44.8 million actually as of yesterday, which surprisingly, I do check this every month or so to also update these slides, is 100% growth over the last 2 months. So that means we added more controls, we added more features that read and write to the database. And we have 1.4 million documents in our database. And that's all customer data, which means there's a lot of stuff in our database that I didn't really have to worry about how to scale, or at least until now, because now we kind of do have to worry about that, especially with 44 million requests. You really want to make sure that you're not running requests. I don't know. I want to make sure that these 100% growth is actually because we've grown by 100% over the last 2 months, and it's not because we're lazy writing our application code and we're putting too much load onto the database. To deploy the Cosmos DB database with Pulumi here on the right, it was literally these couple of lines of code to deploy the database, and then same for each container. So in total, we have 12 containers across 2 regions. And that's our European database. This is our Australian database here, and it's really easy to deploy it via infrastructure as code. Looking at our third-party integrations, buy over build. Just quickly going through this, I mentioned that on the architecture slide. We use Stripe because they are really easy to integrate with, and they have a startup offer. So plus, I don't have to collect any credit card information or other payment information. That all goes into Stripe, which also means that they need to be PCI compliant. We don't need to be PCI compliant, which probably saves us around $100,000 or more a year in audits, which is good. GitHub Actions, we heavily use GitHub and GitHub Actions. We use their fully managed CI/CD GitHub Actions product, and we don't pay anything for it. I checked the other day, I think last month we had a couple of 100 deployments into production, I think, and we didn't pay anything for it. We have Git completely for free. GitHub plus pipelines completely for free. We also use SendGrid because I don't believe that figuring out how to integrate into Office 365 from our Azure function would be worth our time, really. Because SendGrid, integration into SendGrid is done in, again, 2 lines of code from your Azure function. You have an output binding on your Azure function, and that's all you need to put on. And then whatever that function spits out gets automatically sent to SendGrid, and they send the email. Very, very easy. Don't have to worry about running an Exchange server somewhere on a virtual machine, or how to integrate into Office 365 and make sure that we manage spam scores on the internet, that we don't get classified as spam somewhere. All of that, plus metrics and analytics and insights and all of that, SendGrid does for us. And I mentioned Auth0, really, really great identity provider that we integrate with. So if you log into our application, you're redirected to a very familiar login page where you can pick Azure Active Directory or Google, and you log in and you're being prompted for your MFA if you have it, and you really should have it on your as a user. Then all of that out of the box, that whole integration, that whole user experience, we wrote that in 30 minutes in, I think, 15 or 20 lines of code. That's all we had to do. And 10 minutes of configuration, I think, on Auth0's side. And that's it. And they have a good startup offer available. And I think even now, post the startup offer, we pay maybe $100 a month. And that's Aussie dollars. So probably like 60, 70 euros every month for a well-managed, easy to use, simple to integrate identity provider. So far, after being in the market, on production, in production, and very soon on the Azure marketplace as well, what are our conclusions, or my conclusions and takeaways so far? Focusing on the application, as in really everything pass, really focus on writing the application, had very positive side effects. We could really focus on our idea and building this CSPM, and not having to worry about how we, all the other things like scaling, patching, deploying highly available things. All of that was being taken care of by Microsoft. And if we had to make any changes to any of our infrastructure, we just went into our infrastructure as code, made that change, and deployed our pipeline. Really, it comes down for us to more customers. Really meant no worries for us. It just automatically scales. Not worried of being overrun by another 100 customers in a month or something like that. It just automatically takes care of everything. And to give you an idea, over the last 30 days, our front end was hit 11 million times. So that includes the functions here, 11 million times, and less than 1% of those failed, which is fine. And I didn't really have to worry about any of this, which I think is great. I remember back in my SCCM days and deploying Windows Server 2003 via SCCM. It was very, very different. It felt very different compared to this here. And yes, we are locked into Azure. It would be difficult for us to migrate this to AWS, for example, unless we went and just put all the Azure functions into a container and ran Azure functions on Kubernetes. Then, yeah, maybe. But then what about the Cosmos DB? We would have to migrate that to a DynamoDB. What about the front end? What about the identities, the managed identities? We would have to do a lot of work that we don't currently really have to do. It's very simple to hire new talent because we just go and advertise for .NET developer or front-end Angular developer, and that's it. Logging, and they don't actually have to know that much about Azure because infrastructure is done. We don't have to worry about the infrastructure really. And logging was really the most expensive part of the application. We had one month where we misconfigured our application insights a bit and started writing too many logs to a particular output stream. And suddenly I noticed, why was last month around 3 times more expensive than any of the other months? And turns out application insights did get a bit more expensive than it used to be. So we got that down again. Overall, at the moment, we pay, remember, for those 44 million requests to Cosmos DB, 11 million requests to our front end, 1.4 million documents in our database, not having to worry about patching and ops really in general, or traditional ops of virtual machines or IaaS. We pay around 1,500 Australian dollars a month. So probably around 1,100 euros a month. And that's all we have to pay. And on top of that, we just work on the application. I think that's really good. And that all comes down to these initial golden rules that we have. And this is what it can look like then in the end. So if you log into the application, we have this nice dashboard here, which shows you a bit of information about your environment, the top 5 issues in your environment, how many of the detections are actually exploitable. And if you click on one of those, you can then see a bit more information visually displayed here with tags and what kind of virtual machine is it? Is it running or is it stopped? So quite nicely presented to our customers. And all of that runs, as I said, on a static website with Azure Functions and Cosmos DB in the backend. Thank you very much. That should be a clapping emoji. Thank you, Adobe Reader. If you're interested, there's a free trial on ARGOS. It really is a free trial. So you don't click on free trial and then a salesperson calls you. It really is a free trial that doesn't cost anything. We don't even ask for a credit card. All we need is an email address, and we're not going to pester and bother you via email afterwards. Give it a go. It's a 30-day free trial. You can hook it up to your Azure and hook it into Slack or Teams afterwards to get notifications. And if you did decide to become a customer after that first month, or one of your customers wanted to become a customer, we're happy to give a 10% discount on the first 12 months for people here on the call. And if there's any questions, this is how you can get in touch with me. All right, let's see if I can stop sharing or get my camera back on. Let's see what happens. Bloody hell. All right, let's stop presenting, and maybe that's better.
Yeah, you're there.
Yeah, interesting. It doesn't like it doesn't like doing both. I get that bar at the top.
Yeah.
That says, do you want to have the camera and content? And then it dies.
Yeah, but sometimes in the session you were back and now you were gone again. But yeah, the sound was all good and the slides were there, so no worries.
Good.
Was all good. So thanks again for your session, David.